Good morning, ladies and gentlemen. I am Sujin Lee from Kwangwoon University in Seoul, Korea, and so honored to give a presentation on our research. The title of my presentation is Micro-Fabricated Non-Enzymatic Urine Glucose Sensor using Nafion coated Nanoporous PT Composite Electrodes. Here you see the contents of my talk. This presentation is divided into 5 parts. Let me start the presentation with motivation. Using urine dipsticks is predominant in health examination as an indirect diagnostic index for diabetes. But it has many drawbacks. The main drawback is that it doesn't indicate low glucose levels in urine. So electrochemical methods have received considerable attention, which are usually based on enzyme. Although it has good sensitivity, but the lack of stability and lifetime is the main drawback. For these reasons, non-enzymatic urine glucose sensor is proposed, and this sensor has many advantages such as good stability and simplicity and reproducibility. In previous work, many researchers have proposed enzyme-based sensor, as you can see in this table. In previous works, researches based on enzyme sensors. These sensors detect glucose by an immobilized glucose oxidase on the PT or polymer. The enzyme-based sensor has drawbacks such as limit of detection, stability, reproducibility. So in our research, we proposed a non-enzymatic glucose sensor. So in this research, we like to improve the response current and minimize the sensor size by using nanoporous PT working electrodes. And we performed package of the sensor using Nafion membrane to avoid the reactivation of interface species and to avoid electrode fouling. So we applied the fully packaged non-enzymatic urine glucose sensor for healthcare applications. In this figure, you can see the detection mechanism on 2 nanoporous PT electrodes. When the glucose was injected, the glucose molecule reacts much slower than interfering species. So glucose molecule reacts all of the enlarged surface, like orange space, and the interfering species can't recognize enlarged surface, so they react only the top of the space. So let me talk about the fabrication of our urine glucose sensor. The left side of the figure shows the fabrication steps of our research. The type PT are deposited on the silicon wafer as a seed layer, and nanoporous PT is electroplated on the patterned PT. This nanoporous PT electrode has a pore with diameter ranged from 2 nanometer to 5 nanometer. This structure of the characteristic can extremely expand the surface activation area. This is a photo of our sensors. There are 3 electrodes, reference electrodes, and working and counter electrodes. Now I'm going to talk about experimental setup. A 3 electrode system is used, and all measurements was performed at 0.4 volt after stabilizing the background current as a nearly constant value. The ampermeter response was performed under continuous stirring by diluting urine glucose solution. From now on, I'm going to talk about our experimental result. Before this experiment, we carried out cyclic voltammetry response in 1 mole sulfuric acid to clean the electrode surface and to check the surface roughness. After that, we carried out amperometry response of the sensor with consecutive injection of 2 millimole urine glucose. When the glucose was injected, the current increased and its sensitivity was 11.05 microampere per millimole centimeter square. The signal shows a high linearity with a correlation coefficient of 0.9854. The graph shows amperometry response of the Nafion coated urine glucose sensor with various urine glucose concentrations. Different concentrations of stock glucose was injected in PBS solution. Total of 16 times were injected to the test solution of PBS. It responds in 50 seconds to the injection of first 10 micromole urine glucose sensor. It indicates its detection limit was obtained as 10 micromole. And right side of the figure shows the amperometry response of the sensor with various urine glucose concentration up to 22 millimole. This graph shows the amperometry response of the sensor with consecutive injection of 1 millimole urine glucose in PBS. The Nanoporous PT electrode responded quickly to change of glucose concentration and reaches at steady state signals in 15 seconds. So the right side of the figure shows that the signal shows a high linearity with a correlation coefficient of 0.9848. As you can see in this figure, the response at the constant urine glucose was performed for checking long-term stability test. The signal slightly decreased due to the reactivation byproduct on nanoporous, but we could get a cleaning effect of the sensor by applying high potential after final checking. So let me make a quick summary of this presentation. Fully packaged non-enzymatic urine glucose sensors have been fabricated and characterized. Urine glucose sensor with nanoporous PT working electrode showed high sensitivity and extremely low detection limit. Its sensitivity was 0.728 microampere per millimole centimeter squared, and its detection limit was 10 micromole. Biocompatible Nafion membrane was utilized to package the fabricated urine glucose sensor. It has good sensitivity, measurement range, and linearity in various urine glucose concentration. In the future works to obtain the better performance characteristic to optimize the packaging method of Nafion membrane, and various biocompatible materials are investigated. And this is the end of my presentation. Thank you for listening.